Hello, Calc BC students. Today's lesson is really actually not going to be anything about calculus, but a couple topics in pre-calculus that we're going to need in order to be able to do the next type of integrals that we're going to be studying. So the notes are talking about breaking down rational expressions, but I actually do want to start with three problems that are integrals, but we may not know how to do them all just yet. So I'm actually going to pause the video for a second and have you look at these three problems and see if you can tell me which, if any of these, can integrate, and if so, can you come up with the antiderivative? So welcome back. Hopefully you were able to come up with letters A and C and the answers for those antiderivatives. But for letter B, we don't know how to do the antiderivative of that yet. That's actually why we need to be breaking down some rational expressions. So that's what we're going to be looking at next. So in order to do that, we have a couple of algebra and pre-calc topics to discuss. These two questions are going to kind of lead into things that we need for the next section of integrals. So in this first one, it's asking us to simplify this addition problem. So the first thing is come up with a common denominator, and then we'll change the numerator. So the 4 will get multiplied by x plus 1, the x will get multiplied by x minus 2, and if we combine like terms, we'll wind up with x squared plus 2x plus 4, all that over x squared minus x minus 2. The second one is a division problem, and you'll notice that the degree of the top is bigger than the degree in the bottom. So that kind of tells us that we are able to divide. The question is how to do it. You may remember things like synthetic division from Algebra 2 or pre-calc. We're going to stick with straight up long division. So you may or may not remember this, but basically we take the bottom term and divide it into the top term. Now, you'll notice that I did put a 0x squared term in there. That's just to make sure that we have that as a placeholder. So in this case, I'll figure out how many times x squared will divide into 2x cubed. And then multiply that by 4x also. Subtract 0, 0, 0, and then we're left with a 4 at the end. So in the end, when we do the division, we're left with 2x plus 4 over x squared minus 4. So kind of think of that as a mixed number, if you will, for rational expressions. Now we move on to something that was probably in either your Algebra 2 or your pre-calc class, and that is the idea of partial fraction decomposition. Definition is there, talks about breaking a single rational expression into the sum of two or more simpler expressions. In order to do this, we kind of need the ability to factor the denominator. If we can't factor the denominator, really, we can't do the fraction decomposition. So luckily for us, this will factor x minus 3, x plus 2. So the reason for the factoring is because we want to be able to break this into two separate pieces. One piece has x minus 3 as the denominator. The other piece has x plus 2. What we don't know yet is what goes in the top of those two fractions. So in order to figure that out, we're going to basically kind of reconstruct it with a and b. So we're going to say a times x plus 2 plus b times x minus 3 would be the terms if we wanted to put it back together again. And we know that that has to equal x plus 7. So we're basically saying this new numerator has to equal the old numerator, and now we've got to figure out how to do that. So we're going to say basically a times x plus 2 plus b times x minus 3 equals x plus 7. Now there's a couple different ways to do this. I'm going to talk about the way that Mr. Fugay and I have basically shown over the last several years, and that is look for zeros. And what I mean by that is what would make each of these variable expressions equal to 0? Well, in one case, it would be x equals -2. In the other case, it would be x equals +3. Well, if I let x equal -2, then this becomes a times 0 plus b times -5 equals -2 plus 7. And that means -5b equals 5 and b equals -1. So now I figured out what this term in the top of the first or of the one fraction is equal to. It's equal to -1. I do the same thing to figure out the value of a, only I let x equal 3. So if I do that, I get a times 3 plus 2, which is 5, plus b times 3 minus 3, which is 0, equals 3 plus 7, and that's 10. So a equals 2, and again, plug that in, and we've now done what's called the partial fraction decomposition of that original rational expression. Another example, slightly more advanced. This time, we've got a denominator that has 3 factors. So we've got x squared plus 12x plus 12 over x times x minus 2, x plus 2. I'm going to pause for a second and see if you can write out the 3 fractions. Okay. Hopefully you got the 3 fractions that I did, and now it's a matter of trying to figure out how to put them all together. Okay, hopefully you got something like that. We're going to test, or we're going to solve for a, b, and c using the 3 numbers that would make the denominator 0, that being x equals 0, x equals 2, and x equals -2. I'm going to pause, see if you guys can find the values of a, b, and c. All right, take a look at my work and see if you agree with the values of a, b, and c. In each case, I let x equal one of the 3 values that would make the denominator 0, and then I was basically left with one variable and a constant, and that allowed me to figure out what the constant was. So in the end, I would get -3 over x plus 5 over x minus 2 minus 1 over x plus 2 as my decomposition. The last example that I have for today is going to be one where we have to do long division first. And that's because if I look at the numerator, it has a degree bigger than the denominator. So if I look here, That's bigger than that. So that tells me I need to do the long division first. So that's what I'll do. I'll first start by dividing. And I'll go through the process of. So we're going to pick up this problem and I'm going to try and fix the mistake I made before. We're going to multiply x squared by 2x. And now we're going to subtract those terms from the ones above them. And bring down the 5. So what would I have to multiply x squared to make it negative 7x squared? Again, subtract, so I'm going to change all of these signs to positive. So that's going to make it 0x squared plus 18x plus 19. So now I have my fraction written as 2x minus 7 plus 18x plus 19 over x squared plus 3x plus 2. But that's still not all the way simplified because we could still now factor the bottom and do the decomposition of that and break it into two separate fractions. So I'm going to pause it now and have you guys figure out what the decomposition of that would look like. So I hope you were able to get the same two answers that I did. In this case, I got A equaled 1 and B equaled 17. So now the decomposition is 2x minus 7 plus 17 over x plus 2 plus 1 over x plus 1. Now in the next video, we're going to talk about how we can use these integrals to actually find or use these partial fraction decompositions to find the values of certain integrals.